Do y'all not need to because you're here, so you don't need to watch it. But if you ever need to think, oh, what did he say? You can look back at it. Something went really crazy with the factoring video. It's normally everything gets 30 or so views, and the factoring video has 700 something views the last I looked. Sometimes different schools will pick them up. There was a while when I think a school in Japan was using them. We were getting a lot of views in Japan. We were like, oh, wow. Well, if someone's in Japan watching, well, hi. Thanks for watching. But today we're going to continue solving equations. Remember, an equation has an equal sign on it. And the equations we're going to solve today are called absolute value equations. So let's review what absolute value is. Absolute value is denoted with two vertical bars. So this is read the absolute value of x denotes the distance on a number line between the number x and 0. So it's the distance between the number x and 0 on the number line. Okay. The fact that I said the word distance is never negative. You would never expect anyone to, if you ask them, what's the distance from here to Houston, you wouldn't expect someone to say negative 220 miles. Distance has to be a positive number, or, if it's just, I guess it could be 0, okay, if you're in the same spot. So what's the distance from right here to right here? Well, 0. But it would have never make sense to talk about distance being negative. If we had something like the absolute value of, let's say 5, and that's not a 151 that I just wrote.
Try to do the absolute value bars in a different color as the numbers on the end.
Yeah. That's what I'm doing.
So it doesn't look like 151.
So if y'all can picture a number line on your head, in your head, what's the distance between 0 and the number 5 on the number line?
Well, how many units would be there? 5.
What about the absolute value of negative 5? Well, positive 5 is to the right of 0, negative 5 is to the left of 0, but the distance is still the same. The distance between negative 5 and 0, that would just be still positive 5. It doesn't matter if the number in the parentheses, inside the absolute value bars is positive or negative. Doesn't matter if you have a positive number or a negative number inside here. The absolute value, the number over here on the right, is always going to be what? Positive or negative? Positive. Okay? So it doesn't matter whether the number inside here is a positive 5 or a negative 5. The absolute value is still going to be 5. With that in mind, let's try to solve one of these absolute value equations. Suppose we had absolute value of x equals 7. Absolute value of x equals 7. We're going to do this, just logicking our way through, just thinking through. if I covered up that X, could y'all tell me the only two numbers that could be inside those bars? What are the only two numbers that have absolute value equal to 7?
Negative 7 and 7.
-7 and +7. So X is equal to positive or -7? Absolute value of 7 is 7. The absolute value of -7 is 7. Maybe it's time to do one of the problems. Let's do the first one. Oh, okay. Here's problem number 1. The absolute value of X equals 12. You know, there's some problems that in order to get the answer, you got to do a lot of scribble, write. And there's others where you can just sort of get the answer without any of that scribble. What's this? Is it going to take me a lot of scribble to figure out the answer? No? What's the answer going to be? Here's my thoughts. I'm thinking, what's the only two numbers that can be inside here? Only two numbers that have absolute value equal to 12 are
Positive and negative.
Positive and -12. So you can type in either 12, -12, or use that plus/minus key that they have.
There it is. I'm going to use the plus/minus hot button and type in my answer 12.
You'll notice there's an option for the set. The solution set is the empty set. That's another way of saying there's no solution. Well, I'm going to make up an example, and let's see if y'all can figure it out. This one's tricky, okay? Absolute value of X equals -3. Suppose the instructions say solve if possible. Why am I saying that? Well,
remember, regardless of whether the number inside those absolute value bars is positive or negative, when you take that absolute value, what sort of answer are you going to get?
Positive.
So come down here.
Absolute value of X equals -3. What are y'all thinking this answer is going to be on this?
No matter what you put inside here, when you take the absolute value, are you going to get a negative number?
No.
So what do you conclude?
You'll say either no solution or empty set, however they have it worded. That's why there's always that option there. Now, let's see.
You know, maybe we should make this in generalizations. Absolute value equals positive. Absolute value equals 0. Absolute value equals negative. How many solutions?
Okay. Here's some generalizations.
Here's that.
If you have absolute value equal a positive number, that would be like number 1. If you have a positive number over here on the right, there's going to be 2 answers. Okay. Now, if it's an absolute value equals 0, well, there's not going to be 2 numbers here as answers. You don't have positive 0 and negative 0. How many answers will you have then? Just 1 answer.
That stuff inside there has to be 0. If an absolute value is equal to 0, the only way that can happen is for the stuff inside those absolute value bars to be 0 itself. I don't know if that's going to pop up in the homework or not, but it's still interesting to know. And the one that this third case, that's what we just saw in that example here.
Absolute value equal negative. That's one of those no solution or empty set, however you want to word it. And I feel pretty sure one of those will pop up. But I haven't looked at them, so, okay.
And realize the way he's written it, it's the absolute value by itself on one side equals a positive number on the other side. Before you can decide how many answers you have, that absolute value needs to be by itself.
I'm going to make a red star rule. Okay?
Okay, good.
I'm going to say always That's why there's that little cube there, okay? Always isolate the absolute value bars first. If we come across any where the absolute value bars aren't by themselves, we're going to have to use a little algebra and isolate them. So always isolate the absolute value bars first, and I'll put a little red star there. So let's see number 2, see what it looks like. Oh, well, okay. Is this one that's going to, will this require a lot of scribble or not?
Yeah.
Absolute value of x equals, is that a negative 15?
Mm-hmm. We have the absolute value by itself on one side. We have a negative number on the other side. What do we conclude?
No solution.
No solution.
Or, wait, it's empty set? What do they say?
Solution set is empty.
Empty set. Okay. And that's this one, right?
Wait a minute. I'm going to.
So right here, if you have absolute value equal a negative, just like right here. Okay.
Do that.
Okay. And before we do number 3, just to make sure it's clear what I mean by my little red star rule, that you seem to think it's act like it's important. Absolute value of x minus 8 equals negative 5. I'm going to illustrate that red star rule. At first glance, when you see absolute value and there's a negative over here, you might say, oh, it's like number 2, no solution. But wait a minute. Always isolate the absolute value bars first. Oh, you know what? I left out the word bars. Always isolate the absolute value. Let me say bars.
Oh, I think it's okay the way I just say the absolute value. Isolate the absolute value first.
Okay, well. What am I doing? A very poor job of saying we need to do first on this problem. There's only one correct answer to this question. That's the first step. Move that 8 over. You can either draw the arrow or do +8. And hopefully you'll see why I say it's important. If you're going to get the right answer, it's important that you isolate those absolute value bars. Because do we now have a negative number on the right? No. It's just a 3, right?
So it's that first case, the absolute value on one side equaling a positive number on the other side. That means the stuff inside there has to equal what?
What's the actual answer to this problem?
3 or negative 3.
Mm-hmm. Okay. So as we go through these, just make sure those absolute value bars are by themselves. Let's see. So, number 3, The absolute value bars are by themselves. You might think, let's see, absolute value of x minus 7 equals 26. Now this one is going to take more thought. There are some times when we're doing stuff, and you might not exactly understand why it works, like the quadratic formula, but you're just trusting that it works because I say it works and you're following the instructions. Now this is something here that you can understand why. Why am I about to do what I'm about to do? Well, let's cover up. The absolute value bars are by themselves. Let me cover up that x minus 7. If this were like problem number 1, or this one right here, absolute value x equals 3, what are the only two numbers that can go inside these absolute value bars? What are the only two numbers that have absolute value equal to 26? Positive and negative 26. So what we're going to do is take what's inside here and set it equal to positive 26 and negative 26. Figure out.
Here's something I like to do. I like to draw my little brace, and I say that that step inside there has to be 26 or negative 26. Okay. That's sort of hard to see, isn't it?
Mm-hmm. At least with my old eyes, yes it is.
Okay.
But, so you're going to figure out what x value will give us a positive 26 inside there, and then which x value would give us a negative 26. So here, how would I isolate the x? What would I need to do to solve for x? Add 7. I'm just going to do my little arrow on this one, which means plus 7 plus 7. And we get x equals, what's 26 plus 7? 33. So we'll type that number in as an answer. And then over here, move the 7 over. Well, heck, if you want to go plus 7, see, there's two ways of doing it. Either arrow, where you're thinking, okay, move it over and change the sign, or just add 7 to both sides. We're getting x equals, don't say negative 33. It is, it's negative what? 19. So if we plug a 33 in for x, 33 minus 7 is 26. And the absolute value of 26 is 26. If we plugged a negative 19 in for x, negative 19 minus 7 would give a negative 26. The absolute value of negative 26 is positive 26. I have a very technical name for what we just did here. Equal positive, equal negative. That's what we're doing. You take what's inside here, set it equal positive, and then set it equal negative, and isolate the x. So 33 and negative 19. Oh, wow. Problem 4. Okay. Absolute value of 2x minus 3 equals 8. Absolute value. How do I always wind up getting the easier stuff to do?
I'm not sure.
Okay. 2x minus 3. This is not supposed to look like 12x minus 31.
Wait a minute. Equals 8.
I'll move it up, but I first want to make a point. Are the absolute value bars already isolated? Yeah, they're by themselves. So, the number on the right is a positive 8. So what's my thought process? What are the only two numbers? If I covered up that red 2x minus 3, What are the only two numbers that have absolute value equal to 8? Negative 8 and positive 8. So take what's inside there, set it equal to negative 8, and set it equal to positive 8. Or if you want to set it to positive, it doesn't matter which one you do first. Okay? And then just isolate the x. These are called linear equations here because there's no exponents. Now before, when there's absolute value bars there, then that's an absolute value equation. Someone asks you, what did you do in your algebra class today? You can say, we learned to rewrite absolute value equations as two linear equations. Okay? Now, let's see, what would I do here? I'll add 3. So we have 2x equals negative 8 plus 3.
11.
Oh, wait. I'm doing the negative 8 first for no reason. I'm thinking it's going to be a negative 5, right? If you add 3, negative 8 plus 3. Isn't adding 3 what we need to do to get rid of that?
Yes.
And then divide by 2. So negative 5 over 2 is the first answer I got. The way I've worded it, the first answer I got, the order here doesn't matter. Okay. Now over here, what will I get? I will add 3. So we have 2x equals, is that 11? And then divide by 2. And we get what? 11 over 2. I'm just going to circle that. Looks neat in that. When you type these answers in, make sure that you don't put the comma in the bottom of the fraction. You're going to type two fractions with a comma in between them. So let's see.
Here, and I'll type my negative 5 over 2. Then I'll do the right arrow.
Yeah, don't hit the comma when it's down there in the blue box.
Hit the right arrow. Notice the way the cursor is now flashing there beside the 5 halves. I'll type the comma. And then what was the other one? 11 over 2?
Mm-hmm. And you could have typed 11 over 2, comma, negative 5 over 2. It doesn't matter the order. It's just two numbers. But we can't already be up to number 5. There's only 7 questions.
I will have time to start the next assignment. It's a long one, so
So it's gonna bring down their positive attitude. Okay?
I think it's going to bring down your positive attitude.
Well, no, when we start the hard stuff, then you can come over. You're the hard teacher. Okay?
It does seem like that, doesn't it?
Absolute value is problem 5. Oh, actually, the next assignment is one of my absolute favorites. Absolute value of 9x, then a minus 9 equals 27.
Okay.
If you find yourself getting one answer right and one answer wrong, then your mistake is
You're not
You're not
isolating the
isolating
absolute value first.
if you go equals positive 27 and equals negative 27 right now, you're going to get one right answer and one of them wrong. Okay? Unfortunately, what will Pearson do? Will it say, okay, well, good, you got one answer right? Or is it just going to say
Wrong.
Okay? So what's the only correct first step here?
Always isolate the absolute value.
Okay, and on this one, what am I about to do? Move that 9 over. It don't matter if you say like that or if you say this. Either way, you're adding 9 to that 27. So we have absolute value of 9x equals, let's see, 27 plus 9 is 36. Now, if you look at your options, it's theoretically possible this could be a no solution problem, but in actuality, is it a no solution problem? No, you have a positive number over there on the right. So what am I going to do now? Okay, I take the 9x, set it equal to 36, and okay, so first, what are the only two numbers that can be inside the absolute value bars? The only two numbers that have absolute value equal to 36 are
-9 and +9.
What I'm wanting you to say, I'm asking this question very poorly. Only two numbers that can be inside here are positive 36 and negative 36. So we're finding out what numbers, what'll make it a positive 36, and here a negative 36. What I'm doing here is once you have the absolute value bars by themselves with a positive number on the right, just go equal positive, equal negative. Take what's inside there, go equal positive 36, and what's this first answer going to be?
4.
Yep, divide by 9 and we get x equals 4. What about the other one? Negative 4? Will it always go equal positive and equal the exact same but negative? No. Look at number 4. What was it? Positive 11 over 2 and negative 5 over 2. Here it just happens that you do have a positive 4 and a negative 4 is your answer. So you can type them in separately, or if you want to use the plus minus key, that'll work too. Any questions on that?
I think I'll type it with the hot button. But if the plus minus key isn't there, then we would have to type 4 comma negative 4. But as it is, we can just do it like that.
Any questions? What about problem 6?
Oh, this is
Oh, this has got to be hard now because it has a fraction. Absolute value of, what is that, 2x minus 7 all over 3 equals 5. Well, on this one, the absolute value bars are already by themselves. Okay? So there's nothing to do to isolate them. So we go, well, is it a no solution one? We wouldn't be so lucky. The number over here is positive. If it had been negative, we'd say no solution. So just equal positive, equal negative. Take what's inside here. 2x minus 7 over 3 equals positive 5 or 2x minus 7 over 3 equals, what am I about to write? Negative 5. Well, see what I mean by my name that I made up for this is equal positive, equal negative. Okay. Now, I don't know, I was going to cross multiply, but
I was going to ask him what they thought we should do, but you've already said it. I think he was about to write that 5 as a 5 over 1 so that he could start cross multiplying. I think that's the quickest way, and quite frankly, students mess up less when they can cross multiply to solve an equation. If you can write it as fraction equals fraction, people do better at that than...
So like here we'd have 2x minus 7
No, 2x minus 7 times, well,
times 1
okay.
equals, what am I about to write here? 15? Mm-hmm. So add 7 to both sides. We'll move the 7 over, whatever you want to do. I think I'll say plus 7 plus 7. And we have 2x equals the 15 plus 7. Is that a 22? And then what? Divide by 2. So we get x equals 11. So there's one answer. I think the next answer is going to be negative 11. Let's see. I'll do the cross multiplying. 2x minus 7 times 1 is just 2x minus 7 equals this other diagonal. What will that be? Is that a negative 15? So to isolate the x, you do the opposite operation to both sides, beginning with addition and subtraction. So the opposite of subtracting 7 is adding 7. So we have 2x equals negative 15 plus 7, negative 8. And then what do I do? Divide by 2. And we're getting x equals what? Negative 4. So positive 11 and negative 4. Are y'all caught up? 7. Okay. Oh, you've already switched. Okay, 7. Oh. Okay. Absolute value. What is that?
M
plus 1. And then a plus 9 equals 11. I'm trying to make these absolute value bars a little bit bigger. I don't want it to look like 1m plus 11. Yeah.
There's only one correct first step to this problem. Minus the 9.
Yes.
We need the absolute value isolated before you do anything else.
So we have absolute value of m plus 1. And at this point, I'm going to hope I have a negative number on the right, so I can say no solution and stop. Am I that lucky? No, 11 minus 9, 2. But either way, after everything y'all did in the last assignment, this ain't that bad, is it? What am I about to do?
Drop the absolute.
I drop the absolute and then go equal positive 2 and equal negative. So m plus 1 equals positive 2 or m plus 1. You know, to be this is the last problem. It's not that bad, is it? M plus 1 is negative 2. So let's see. What do I want to do? Subtract 1. What's our first answer we're getting here? M equals 1. 2 minus 1. And what's the other answer? Here when we subtract 1, what are we getting? -2 minus 1, -3. Is that what I heard? That's right. So 1 and -3.
1 and -3. So we type 1 and -3. Okay. Okay. Now, I have some. The reason you may be thinking to yourself, if you follow what the Coordinating Board on Higher Education dictates for classes and stuff, you may be thinking to yourself, well, absolute value equations is taught in Math 371 developmental math. Why are we doing it here? Because we have to solve absolute value inequalities in this class. An inequality is something that has a less than or a greater than, less than equal to or greater than or equal to. The reason we're reviewing, well, not really reviewing, we're teaching it, okay? The reason we're teaching solving absolute value equations is the first step to solve an inequality is to solve the equation. So you need to solve the equation, and there are some rather messy absolute value inequalities in the next homework assignment. The long part of the problem is solving the equation. So I want to take a moment and solve those equations. Those 2 examples that I made up, that wasn't recorded. Sorry about that. Okay, and now I want to look at something called interval notation, and you may have seen it in other classes, and if you didn't, it's real easy. Easy to learn means
it's easy to forget.
So you saw it somewhere, but you might not remember.
Let's
You want to use
suppose
those same
I
numbers?
do. Okay.
-6, -5, 4, 5. It's a cross out. Now put some openness.
Okay. I'm going to put these numbers that I've labeled here on this number line, for lack of anything better, I'm going to call them cut points. I labeled 4 numbers on the number line, and some of those numbers are going to be labeled with open circles. Some of them will be labeled with closed circles. We're going to go through a process in class the next time to decide. We'll find those numbers that are called cut points, and then we'll figure out how we want to label them. That is open or closed. I'll have an open there and a closed right
Just
here.
to humor me, label one more number on here. Maybe a 7 right there.
Okay, so I'm going to put another number there, 7, and I'll have it.
Well, that number line closed.
Yeah. We'll go through this little process, and
we'll get these cut points.
And we'll get these cut points, and then we're going to go through. We'll have a little method, and we'll decide. Okay, we're going to let's shade this, and then we're going to cross that one out. And for the just for the sake of this example, shade. Cross out, shade, well, we did.
I know, I never do start off with a shaded one, but okay.
And cross out. Okay.
We're going to label the shaded portions using brackets and parentheses, but first let's label what these open circles and closed circles mean. The open circle means you're not including the number.
It's not shaded in. -6 is not going to be included in the intervals. Whereas the closed circles, it's shaded just like these numbers to the immediate right of -5. So let's see.
In words, the area that's shaded here are the numbers between -5 and +4, including -5, not including +4. So make a note that an open circle means not including, and a closed circle means including.
So open circles we're including that we're
No,
not
not
including. A shaded is included. So we want to express all the numbers on the number line that are to the left of -6. That's what we're looking at this first interval. How do we express the interval, all the numbers to the left of -6, but not including -6? You read it from left to right. You look here and you ask yourself, what's the left-hand endpoint? There isn't one. So to indicate that this thing just keeps going and going forever in the negative direction, you'll put a parenthesis and a negative infinity, comma. The right-hand endpoint is a -6. At the cut points, there'll either be rectangular brackets or parentheses based on whether the cut points are open or closed. If it's open, you'll follow that number up with a parenthesis. This is saying all the numbers to the left of -6, not including -6, just the numbers to the left of -6.
And not including infinity. It wouldn't make sense to talk about including that arrow. I like to label this arrowhead over here on the left negative infinity.
Or we're going to another interval. We put a stylized U. That's a union symbol that you'll find on the toolbar when you're typing these things up. Now the next interval. Okay, you go from the left-hand endpoint to the right-hand endpoint. You go small to big. So the left-hand endpoint is a -5. But notice how it's closed there. So we're going to put a bracket, a rectangular bracket, in front of that -5. Closed circles have rectangular brackets. Open circles have parentheses, comma. The right-hand endpoint is a 4. It's not shaded in, so you're going to put a parenthesis. Or another one of those unions that'll come from the toolbar. By the way, the infinity symbol, that'll be on the toolbar also. Okay, this interval that's shaded here, bracket, 5, comma, 7. What am I going to put after the 7? A bracket or a parenthesis?
Bracket.
A bracket because it's closed also. And this is called interval notation. By the way, the parentheses and the brackets, you'll take those from the keyboard. Just use the bracket and parentheses from the keyboard. And I think we need one. Well, first of all, any questions on what we've done?
This notation says, if someone asks you, which regions on that number line are shaded red?
Intervals. Which intervals?
No, I'm going to say regions. Well, everything to the left of -6, that's what this is saying, not including -6. Everything between -5 and 4, including -5, but not including +4. Everything between 5 and 7, including 5 and including 7. You might think, well, wait, what is that? Just 6, 5, 6, 7? Think of all the decimal numbers. There's a whole lot of decimal numbers between 5 and 7. 5.1, 5.2, and so forth. Okay? Let's see, I think I'll do closed and open. And
I'm going to shade. Cross out and shade.
Now label this left-hand arrow negative infinity and the right-hand arrow positive. Just so you see, you're going to be going left, right, left, right. Here, the order matters. Everything you have written in interval notation better be in the same order that you see on the number line. Okay.
Okay. This left-hand interval. We'll go through a process. We'll come up with these numbers that we have to label on the number line. Some will be shaded, some will be unshaded. Then we'll go through and decide, oh, shade one interval, don't shade, shade. And then the final step in the process is to write those shaded intervals as interval notation. So let's write this left-hand interval using interval notation. Well, there's no left-hand endpoint, so we use a negative infinity, but what you always put in front of a negative infinity is a parenthesis. You don't put brackets in front of a negative infinity. And bracket means that you get to that number and you stop. This symbol here is not a number. You can never get there and stop. That just is a symbol representing the abstract concept. Just keep going to the left forever. So we have a parenthesis, negative infinity, comma. We have a -6. What will I put after the -6? That's a bracket. Union. Now this other interval. Okay, it's not shaded, so I put a parenthesis, 3, comma. The right-hand endpoint, well, there isn't one. It just keeps going and going forever. So you put a positive infinity. Notice there's no sign there, so that means you assume positive. Always put a parenthesis after a positive infinity. You always put a parenthesis in front of a negative infinity. You always put a parenthesis after a positive infinity. Any questions there? Okay, let's see. If y'all understand this, you'll be able to tell me which interval contains the numbers 0, interval 1, 2, or 3.
Where's 0?
Where is 0 located on this number line? There, interval 2. 0 is between -6 and +3. Where's -10? And which interval is -10 located? Interval 1, 2, or 3? Okay, the first one. It's out here to the left of -6. Suppose I wanted 50. Where would 50 be labeled on this number line? Or be located? Interval 1, 2, or 3? 3, okay.
Now, real quickly, on Canvas, you have some files. And the one that we're going to be using on Monday is this one right here. It's called Cut Point Method. Open that up. This is the recipe that we're going to solve or use the next time. You don't have to worry about steps 1, 2, 3, 4 right now, but step 1 and 2 tell you how to find those cut points. Step 3 tells you how to shade the number line. No, how to label open and close circles. You've already done that. Step 4, how to shade. What I wanted to look at is step 5. When you get to step 5, you will have drawn a number line. Oh, it's a blade of Zoom. You'll have a number line drawn with shaded intervals. And here's step 5. That's what he's been doing, is reviewing this interval notation. Use a square bracket for closed circles. Yeah, we said that. Use parentheses for open circles. Yeah, I said that. Always use parentheses for infinities or negative infinities. I think I said it all. Yeah. And so this little recipe will solve any type of inequality. For which there's a solution to find. I would modify it and solve it when I had to find, trigonometric inequalities.
Oh,
Yeah,
I know. I've used that before. It'll solve anything that has a less than or greater than. I remember an employee here once saying, I don't know why that cut point method of yours works, but it works. And I was like, oh gosh,
You don't know.
you don't know why.
Oh, wow.
But you may not know why, but I know why this works. And we'll try to explain why it works, and it's the best thing to use whenever you see a less than or greater than. But that'll be on Monday. Keep in mind, you've already done the hardest part of the stuff on Monday. That right there. Okay. So don't let the assignment worry you or make you think, oh, it's going to be really bad. That's the hardest part, what he did right there. That stuff. So if there's no questions, we'll stop the recording and call this class over. And if there are some questions and you don't want them recorded, we have plenty of time to answer them. So we'll see y'all on Monday.